Okay, Unit 2 review. Evaluate each expression. To the 1/2 means the square root, so this is the square root of 4, or 2. To the negative means it's 1 over, so this is 1 over 5 squared, or 1 over 25. Now we have both power with the numerator and denominator, so this is going to be the square root of 16. There I take care of the 2, and now I've got 2 the third. Now I could put the third inside, but I'm going to find it a lot easier to work with if I do square root of 16 first. So square root of 16 is 4. So this is going to be 4 to the third. So that's now 4 times 4 times 4, which equals 64. To the 1/2 is the square root. To the 3/4, so this is the 4th root of 81 to the third. So this is 8 plus the 4th root of 81 is 3 to the third, which is 8 plus 27, which is 35. All right. 1/9 to the negative 1/2. First thing I'm going to do is take care of the negative. That means it's flipped. That's 9 to the 1/2. Right? All I did was take care of the negative. So 9 to the 1/2 is square root of 9, which equals 3. The cube root of 32 to the third. A little tricky here. So notice, though, that I'm going to say this is 2 to the 5th. Actually, I don't even need to do that, to the third. But I don't even need to do that. Unnecessary. Unnecessary. Ignore that. Okay, anytime we take something to the third, right, we could say x to the third and then take a cube root. That would be x. So this is going to be 32. Okay, negative. So 1 to the, here's the thing, 1 to the anything is always 1. Because it doesn't matter, right, if you take 1 times 1, that's going to be 1. 1 divided by 1 equals 1. So using that principle, it doesn't matter how many times you divide 1 by itself, how many times you multiply it by itself. 1 over 1 equals 1. So all that means is that this first term is going to be 1. And then if you recall, to the 0 means that we're dividing by the same number of things that there are. In other words, this is like negative 6b to the 1 over negative 6b to the 1. Right? So when you take something and divide it by itself, that gives us 1. So we basically got 1 plus 1, which equals 2. All right. Last one, we got a whole mess of stuff in the cube root. But remember, just like we have, if we have something with an exponent on it, that exponent applies to all of those things. So this would be the cube root of 27 to the cube root of x to the 6th times the cube root of y to the 12th times the cube root of z to the 6th. In other words, we're taking each of these and we're applying the cube root to, or we're multiplying the third times one of the exponents. So in this case, the cube root of 27 is 3, and then we just say, okay, well, what's 6x to the 6 thirds, y to the 12 thirds, z to the 6 thirds. That's what happens, is this exponent on an exponent multiplies. So then I've got 3x squared, y to the 4th, z squared is my final answer. The approximate number of calories is given by this, where m is the animal's mass. Find the number of calories of the dog with a mass of 16 kilograms. What does it need each day? So m equals 16. So calories is equal to 71 times 16 to the 3/4. Remember that the exponent comes in order of operations before multiplication. So this is going to be 16 to the 3/4 is going to be the 4th root of 71 times the 4th root of 16 to the 3rd. So that's 71 times 4th root of 16 is 2 to the 3rd. 71 times 8. Okay. And for this test, we're going to be making sure we give you a guide to some simple calculations of cubes, squares, and to the 4th powers, but not calculators. So we are going to be giving you numbers that are even easier than this to multiply. But multiplying this, 8, 7 times 8 is 56. So 568. So the answer is 568 calories. Yuan is asked to evaluate the expression -8 to the 2/3 on exam, and he says it's unsolvable because you cannot evaluate a negative number even to a fractional power. Is he correct? If so, why? If he's not correct, what is the correct answer? Well, no, that's not correct. Here's why. What we're saying when we say -8 to the 2/3, that's the same as -8 to the 1/3 squared. So we can't take a square root of a negative number, because we can't take a negative number times a negative number is always going to give us a positive number. But a cube root, we can. So we're saying what times what times what gives us -8, and that, sure enough, is 2. So this is -2, and then we square it. 2 times 2 is 4. So he is not correct. This is the correct answer. Okay, number 4. Degree, leading coefficient, standard form. This is not something that we covered. We decided to skip over it, or I did, so we can just ignore that. Simplify A, B, and A's and B's and A's and B's. We need to combine like terms. So look, I've got an A and a B squared in this term. Here I've got an A squared and a B. So the exponent belongs to the B. That doesn't combine with this. But here's another AB squared. And here's another AB squared. So I've got 1 plus 6 minus 5. That's 7 minus 5 is 2. So I've got 2AB squared. And then look, I've got no more A squared B's. So that's minus 17A squared B. And only one number by itself, a constant, plus 2. Adding polynomials. Notice there is nothing multiplying itself except what's already in the term, right? So 5x never multiplies this 5x. It's just minus, minus, plus, plus. Since we've got a plus in front of the parentheses, that means we don't even have to worry about flipping the sign. It's just 9x squared minus 5x minus 4 plus 5x squared plus 9. And then we combine like terms. There's a 14x squared. Then I've got one term with just x, and then I've got a plus 5, and there is my final answer. Same with this one, right? So look, I've got a squared b to the 3rd, a squared b to the 3rd. So I've got a plus 4 and a minus 7. That's minus 3a squared b to the 3rd. Then I've got a plus 3a squared b, excuse me, a cubed b, and here's another a cubed b. So these are like terms. So minus 5 plus 3 is minus 2a cubed b. And then we've got an ab term, minus 9 and plus 1. So that makes us minus 8ab. So don't make these more complicated than they have to be, unless you see something right next to a parentheses. If you see a plus or a minus next to a parentheses, that means you're not carrying things over and distributing them. There's no box method. It's just adding and subtracting these polynomials. Okay, for subtracting, highly recommend that you go ahead and just write this out. Minus 2r, and then the minus makes this a negative 7r, and a minus makes a minus 6. And I like to see things all in the same penmanship and not have to go between my handwriting and the typing. So I'm just going to write it all out like this. It's going to be much clearer to me to do it this way than to try and scribble in different things. So I've got 4r squared minus 2r squared. That gives me 2r squared. Here's a plus 9r and a minus 7r. That gives me plus 2r. And here's a minus 4 and a minus 6 gives me minus 10. Same thing here. 2x squared plus x minus 3. Nothing multiplying this thing, right? It's its own polynomial. There's no multiplier on either side. The only thing that is multiplying by this is this negative 1. Minus 1 times. So this becomes plus 3x squared. Minus times minus is plus 5x. And minus 6. And now it's again combining like terms. Here I've got 5x squared, 1x, and 5x is plus 6x. And then I've got minus 3 and minus 6 is minus 9. Okay, it even tells you add and subtract. And here it tells you multiply. Now I'm going to demonstrate the box method on this one just to show you that you can always use this method. Our experience in the past as math teachers, mine included, is that those who consistently use the box method do better on tests, on this test and on upcoming modules. So I encourage you to get used to using this. It's really going to help you when we start working backwards and factoring these kinds of things. So 5 times 6 is 30. X squared times x cubed is x to the 5th. This is plus 50, and then we've got an x squared and an x squared, so that's 4 x's, and then a y, and now we've got minus 15x squared y. Here is where you're multiplying. 30x to the 5th plus 50x to the 4th y minus 15x squared y. Okay? Since you've multiplied these things out, and since it was just one term here, monomial, multiplying these three, since these things weren't combined, the inside isn't going to be combinable either. They're not going to have any common factors except for, you know, this. But the point is that these would have been already combined if you could combine them. So there's no combining these because they're just added and subtracted. And remember, the only time you can add or subtract terms like this is if it's the exact same combination of variables and exponents. Okay, this one, notice there's no addition or subtraction. It's just everything multiplied by itself through. So this is 5 times 7 times x cubed times x to the 4th times y to the 6th times y to the 3rd. I'm writing them out just in a different order because you can do that with multiplication. It doesn't change the outcome, and it can. This allows me to see, look, I've got 1, 2, 3, 1, 2, 3, 4, so I've got 7 x's, and then I've got 6 y's and 3 y's. That makes it 9 y's multiplied together. Okay, box method is your friend here. 4x minus 3, x plus 5. It doesn't matter if you go in a different order. If you want to put the 4x minus 3 up top, that's fine. 4x squared plus 20x. Remember, we're multiplying. Minus 3x and minus 15. Okay, these now, these combine because you've got an x. So 4x squared doesn't have any other like term within this. But look, I've got a plus 20x and a minus 3x. That's plus 17x. And then minus 15. Okay. This one will work the same way. Those of you with some practice on this and are practice in pattern recognition, who've trained your brains that way, are going to notice that this is going to set us up as a difference of squares. But the box method will work for us. So this is 9x squared. This is 30x. This is negative 30x. And this is negative 100. You'll notice that the 30x and the minus 30x, these cancel each other out. Cancel. So I'm left with 9x squared minus 100. X cubed minus 5 squared. So that means this is x cubed minus 5 times x cubed minus 5. So we can turn this into the box method. X cubed times x cubed is x to the 6th, minus 5x cubed minus 5x cubed, and plus 25. So notice these, they don't cancel each other out because they're both negative. So this is x to the 6th minus 10x cubed plus 25. All right, and F. So negative x cubed plus 7x squared minus 4x, 2x, and minus 1. Box method. Again, if you do this correctly without the box method, more power to you. I'm not going to say it's going to work well for you later on when we have to do it backwards, but, you know, work with what works for you. But if you're not 100% on doing these, use the box method. Learn it. It will help you. Trust me. I've seen other students who, once they get this, it really helps. Okay, so this is negative 2x to the 4th. That's a little tricky because the negative comes from here and the 2 comes from here. But remember, this is negative 1. So we've got negative 1 times negative 2. 2 times 7 is 14. X times x squared is x to the 3rd. Do not forget, just because this is an x, it doesn't mean it's nothing. It's an x to the 1. So that's 1, and 2x's makes 3 x's. Here is negative 8 x squared because we've got an x times x. So it'd be really